All right, let's differentiate the following with respect to x. And if we consider part A, where f of x is equal to the cube root of x, we're going to differentiate using the power rule. So to use the power rule, I need to change this radical into an exponent. Now we can understand the conversion where if x is a base to a power x a over b, then we can rewrite the exponent as x to the power a to a root of b, right? And b is the index and a is the power on the radicand, right? So what you want to do, if you convert this radical in the form of an exponent, then you can rewrite this as f of x is equal to x to the power 1/3. Then using the power rule, we know that if f of x is equal to ax to the power n, f prime of x is equal to a times n, x, and you subtract 1 to the power, so n minus 1. So using this notion, right, f prime of x is equal to 1/3 x, 1/3 minus 1, which is negative 2/3. Okay, if you wanted to write this as purely positive exponents, you can write this as 1 over 3 x to the power 2 over 3, right? And this is perfectly fine as well. Okay, so this is your derivative. Okay, let's take a look at part B. So part B, we have y is equal to square root 3 x square root 2 to the power of square root 2. And what you want to figure out here is dy over dx, which is the rate of change of y with respect to x. And once again, we're employing power rule. The only difference is that the power, instead of having a concrete natural number, we actually have an irrational number in the form of a radical, right? But we still employ the same rule. So we do square root 3 times square root 2, right? So square root 3 times square root 2, and you can use the radical rules where you multiply the radicands, and then x square root 2 minus 1. So this is basically square root 6 x to the power square root 2 minus 1. And the thing is, you can leave your answer like that because of the fact that square root 2 is rational and it's going to contain decimals, so this is actually going to be more exact. And that is the derivative of the following.